Hi everyone. So I had a couple of requests to do a video on our newest method to solving quadratics, which is completing the square. This can be used as review for the upcoming quiz, for the unit test that's planned for next week, or especially for those people that were absent on the days when we learned this method. This is a great way to go over it. So to keep this video short and sweet, I went ahead and wrote down the 5-step process that we should be following when we're using the method completing the square. And then I also wrote down 4 examples that I'm going to go through in this video. So go ahead and grab a notebook, a piece of paper, anything that you can write on, and I encourage you to work along with me because it's more important for you to know how to do it than it is for you to watch me do it. If you want to pause the video right now, you can copy down the steps, copy down the problems, or even better, if you pause the video right now, you can try all 4 problems out on your own and then watch the video through to see if you are getting them right. So here we go. Completing the square is the method that we use if we have a quadratic that has both x squared and x to the first power, so our isolation method can't be used, but then we're dealing with something that can't be factored. And I highly encourage you guys to take some time to investigate the quadratic that you're looking at, because if it is factorable, 9 times out of 10, that's actually easier to do. If this was a trinomial with a 1 in front of the x squared and I could find 2 numbers that multiply to the constant and add to the linear term, I can finish this problem in 2 steps by factoring and setting each factor equal to 0. But unfortunately, there are no numbers that multiply to 12 and add to negative 10, so we need to find a different method, and that's where completing the square comes in. So step number 1, I'm going to make sure that a is equal to 1. Remember, a is the number in front of x squared, so in my first example, we're good. Anything that's not written in front of the x squared is an invisible 1. Step number 2, separate the variables from the constants. We're going to use the equal sign like a wall. So where I have my full trinomial on the left-hand side, I'm going to go ahead and subtract the 12 over to the other side of the equal sign so that I no longer have it next to my variables. Now, what I like to do is I leave a space where that 12 used to be, because I'm going to generate a trinomial that actually is factorable, right? And remember, we're dealing with equations, so anything I do to the left-hand side of the equal sign, I have to do to the right. So step number 3, we're going to go ahead and complete the square, and the goal of this is to not only make a factorable trinomial here, but to make what's called a perfect square trinomial. And this is a trinomial that's going to break down into 2 identical factors, so we'll be able to write it one specific way. And in order to do that, you use this formula b divided by 2 squared. Okay, so in this example, my b is a negative 10, and I'm going to come over here and I'm going to plug negative 10 into our formula where that b is. And you could go ahead and plug that into your graphing calculator the way that it's written, or if you just do a little bit of mental math, it's not too hard to do. Negative 10 divided by 2 is negative 5, and if I take negative 5 times itself, which is what it means to square something, I get positive 25. No matter what you're squaring, the number you add to both sides is going to be positive. So you'll notice I already had the plus sign there before I put the blank. I just need to fill it in with what number. All right, so here on the left-hand side, I have a perfect square trinomial. So if I go to factor this, I see a simple trinomial with 1 in front of x squared. I ask myself, what multiplies to 25 and also adds to negative 10? And if you did it correctly, you should get 2 identical factors. Negative 5 and negative 5 are the numbers I'm looking for that multiply to 25 and add to negative 10. Now, this is always going to happen where you have the same number in both factors, so we're actually going to write it as that 1 factor squared, because this is going to be able to be solved. So we're going to be able to move forward with that. On the right-hand side, negative 12 plus 25 is equal to 13. So I just jumped a line simplifying those 2 together. And from here, we're going to follow step number 5, which is to finally solve for x. So I have my variable showing up in one space. If I could just get it alone, then I can tell the reader what x equals. So we're going to take the square root of the left-hand side to get rid of this exponent of 2. These inverse operations will cancel, and I'll be left with x minus 5. Balancing it out on the right-hand side, every time we take the square root of a number now, we're going to put a plus minus sign on the next line. in high school, we talked about how square roots can have two possible answers, positive or negative versions of the principal square root. All right, now what's interesting here is if I look at the square root of 13, not only is 13 not a perfect square, but it also does not have any perfect square factors. So besides punching it into our calculator and using the long crazy decimal that our calculator gives us, the only thing that we can do is copy down exactly what it is, because that long crazy decimal is actually an irrational number that goes on forever. So to hold the true value of square root of 13, we're going to leave it as the square root of 13. Okay. And the last step, if I have x minus 5 and I want it to just be x, I'm going to add the 5 to the other side. Now be careful in this step. This is a 5, positive 5, regular number, and this is a 13 that's underneath a square root. So this isn't really a 13, which means that I can't combine it with that positive 5. So what I like to do is I like to write the number I moved over first, and then I bring down the plus minus symbol in front of the square root of 13, because that will show me my two possible solutions for x, either 5 plus radical 13 or 5 minus radical 13. Okay, so that's the example that I'm going to explain the most. As we go through the other four, I'm going to show you, the other three, I'm going to show you some specific things that might come up to keep an eye out for. But this is generally following the 5-step process. This is what you're going to do every single time. Okay, number 2, I have a equal to 1, so step number 1 is done. And step number 2 is done because I have my variables on the left and my constant on the right. So we're already almost halfway there. What I'm going to do now is I'm just going to make this x squared plus 6x become a perfect square trinomial by adding one specific number. And if you take that b value, which is positive 6, put it into your formula, you should get positive 9 to add to both sides. So this perfect square trinomial would factor down into x plus 3 squared. 3 times 3 is 9, and 3 plus 3 is 6. So that's the number I'm looking for. And 41 plus 9 is 50. So as I take the square root of the left-hand side and the right-hand side, I'm going to be able to knock out that power of 2, be left with x plus 3, and I'm going to have a plus minus symbol in front of my next value. Here, when I have the square root of 50, get into the habit of reducing all of your radicals into simplest form. If you can, take that step. Otherwise, you might lose partial credit on a question that asks you to write it in simplest radical form. So over here on the right-hand side, off to the side, not interrupting any of my work that I did over here, I'm going to go ahead and try to reduce the square root of 50. Use a factor tree if you like, but I know that two numbers that multiply to 50 are 25 and 2, and I'm going to use those two specific numbers because 25 is a perfect square. So go ahead and answer this question with a 5, bring down the radical 2 that it's multiplying by, and I can write that instead of the square root of 50. Okay, this is in simplest radical form. So just isolate the x by subtracting 3 to the other side, and you would get x equals negative 3 plus or minus 5 radical 2. Okay, question number 3. In this case, I do have 1 in front of x squared, so my a is equal to 1, but I have a variable on the left and a variable on the right, and I want them to all be on the same side. So I'm going to go ahead and subtract the 2x to the left to separate it from the constant negative 10. And in the same step, I'm going to go ahead and put in that blank space because at this point, I know what's coming. So I'm going to take my negative 2, throw it into my formula. Negative 2 divided by 2 is negative 1. Negative 1 squared, be careful, is positive 1. And I'm going to add that to the other side. Okay, my left-hand side is a perfect square trinomial. So they will always factor down into x squared. I just have to fill in this blank. What multiplies to positive 1 and adds to negative 2, or what's half of negative 2? So that would be negative 1. Simplify the right-hand side and you get negative 9. Now our next step would be to solve for x by taking the square root, and I'm going to be able to eliminate that exponent and be left with x minus 1. Now when I go to balance it out and take the square root of the right-hand side, although it's tempting because that 9 is a perfect square, it's not a 9. It's a negative 9. and you can't take the square root of any negative number, so that is an issue right there. And no matter what method you choose, no matter what quadratic you're working with, if you get to the point where you're taking the square root of a negative, it cannot be done. So from here, I stop all my work. My final answer would be no solution, because there is no x value that's going to satisfy this statement, because I can't take the square root of negative 9, which means there's no x value that I can plug in here and get a true statement either. All right, last but not least, number 4, and I saved the best for last. Okay, number 4 is the only one that has a number in front of x squared. It doesn't come up as often, and if there is a number out in front, you might not go with the completing the square method. We're going to learn about other ways to solve quadratics this week. But if you follow the completing the square process, in order to make a equal to 1, all we have to do is divide by that number that's in front. So luckily, all of these numbers are divisible by 4. So when I go ahead and divide both the left and right-hand side by 4, I'm going to reduce my quadratic equation down. That's 1x squared, that's 8x, negative 4, and that's 0. And now I have written an equivalent equation that starts with a 1x squared, which I need to complete the rest of the steps. So I'm going to go through this one silently so that you don't have to deal with my voice anymore, but try it on your own. All right, and I think I finished that problem up maybe about a minute. So once you get enough practice with this, and once you get the hang of it and it starts to click, you'll be able to breeze through these completing the square processes in no time, because it is the same 5 steps, just dealing with different numbers every single time. Okay, the thing you guys need to keep an eye out for is to make sure that you reduce all your radicals when you can. Okay, don't get tricked by the negatives. You can't take the square root of a negative. And make sure that you divide by the a value if it's not already equal to 1. If you have any questions on this, come into Extra Help. We can go through a couple problems together, and I promise eventually it's going to click and you'll get the hang of it. Have a great day, guys.